Hello everyone, welcome back. This is your friend One Punch Coder. Today we're going to take a look at Leetcode question 1386, Cinema Seat Allocation. If you haven't read the question yet, please pause the video and take a look at it. Now I'm going to assume that you already know what the question is asking. I think this is a really good question to practicing a technique called masking. So if you don't know what masking is, you can take a look at the Wikipedia thread here. It's a very useful information. But the basic idea is that we use binary 1 and 0 to represent two different states. So in this situation, this question, two different states will be either reserved or not reserved. So we can say reserved is 1 and not reserved is 0. And we're going to use binary to express this state. And now here is my approach to this question. So first, I will masking each row in reserved seats using binary expression or bitwise operation. And second, I'll iterate through each masked row and verify how many four-person family it can take. So before I get into my solution, I think there are a couple things you need to know. First, you need to know how to make the ice bit from the right as 1. And second, you need to know how to verify the ice bit alpha number is 0. And here's my note. So to make the ice bit of a number as 1, we can do left shift. So in this example, if we want to make the third bit as 0, we can left shift 1 twice. Then we get 100, which is a decimal of 4. Okay, you get the idea? And the second thing is how to verify the ice bit from the right alpha number is 0. And the same example here, we're gonna do a OR operation. The other thing you need to know is that how to verify the ice bit from the right alpha number is 0. So if the third bit of these two numbers are 0, then the third bit of their OR operation will definitely be 0. Otherwise, it will be 1. So once we know these things, we can start our solution. So first thing I'm going to do is masking each row in reserved seat. I'm going to start with a dictionary collection default dict, and for row and column in reserved seat, we're going to have masking. Here I'm going to use the first thing I talk about, how to make the ice bit as 1. So for each reserved seat, I can mark it as 1. And here's what I'm going to do. I do a 1 left shift C minus 1. Okay, and now I finished the first part already. And then here I'm going to assume that for all rows, they can take two four-person families. Note that this is only an assumption, and you will know why I'm doing this in a bit. Now I'm going to iterate each masked row and verify how many four-person families they can actually take. So for row and binary in the items, we want to verify how many four-person family it can take. So at what situation it can take two four-person families? Only when the column from 2 to 9 are totally empty, like the example here at the third row, then it can take two four-person families, right? I did some pre-work here, so the masking for that will be the binary like this. And the corresponding decimal is 513. So I'm gonna use that in my expression. Here, if binary OR operation, and this is the second operation I'm talking about right here. Okay? We're gonna do an OR operation, wins 513. If it's equals to 513, then we don't do anything because it can actually fit two 4-person families. And we're gonna verify the rest for 4-person families. I'm just gonna copy this, or that's 903. 903. And at this situation, this row, meaning this row can only fit 1 4-person families. That will be answer minus equals to 1. And for all the rest cases, it can fit 0 4-person families. So we do a -2 there. And that's it. We're gonna simply just return the answer. Let's see if this works. Okay, it works with test cases. Alright, it works. So, as you can see, this question isn't that hard, and by using bitwise operation or bit masking, we can save lots of coding works on doing comparisons. And also, using bitwise operation is pretty efficient. So I think this is it. Hopefully you learned a little bit something today. I'm your friend One Punch Coder. I will see you next time. 加油呢